This video is for standard form of a quadratic, and in this particular scenario, Larry throws a stone off a bridge into a river below. The stone's height in meters above water, x seconds after Larry threw it, is modeled by the function that's given in here. So stone's height would be our y, x seconds or time would be our x. And using the key information that's given in our standard form graph equation, we can get a graph that looks like such. Here is our graph. You can see from the equation that it's negative. It allows us to go ahead and have this downward shape, a vertical reflection, very similar to had we had a negative in intercept / factored form and had a negative with vertex form. A negative from front provided it. And now we also notice that we have one key point on the graph. Hopefully we recognize the 15 coming from the equation matches up with the value that is there. Well, we want to answer some questions regarding this scenario. First off, how many seconds after being thrown will the stone reach a maximum height? Well, this comes from the feature of the h value, or x coordinate of the vertex, which would be right here, which is currently unknown. Standard form does not help us find that answer. Well, what is the maximum height of the stone above the water? What is that height that occurred at the time interval? Well, once again, this we are unable to find as we are looking for the k value, or the y coordinate of the vertex, which is unknown. What is the height of the stone as it was thrown? Well, this is the y-intercept, and we can see that this occurs at 15 meters, which is provided from the equation of standard form. Well, how many seconds after being thrown will the stone hit the water? Envisioning the path of the stone, we see Larry throws it, it reaches a maximum, and comes down and splashes into the water. However, we don't know what time that occurs at. So we do not know the values of the x-intercepts from this standard form of a quadratic. Well, in terms of figuring out increasing and decreasing, we once again need the h value, or the x coordinate of the vertex, which is that point. We can see that the graph is increasing on this side and decreasing on this side, but we don't have any key x values to go ahead and break that up and provide answers. So we cannot determine increasing and decreasing directly from standard form. We also cannot determine positive and negative directly from standard form, as we do not have the x-intercepts to determine where the graph is positive and negative, where that is broken up from the graph. In terms of a reasonable domain and reasonable range, in terms of reasonable range, how far left to how far right, the question is what times or amount of seconds make sense in this particular scenario? Well, it makes sense to start at 0 seconds in terms of when the time in the scenario begins, but we don't know the other x-intercept in our particular problem, so we don't know when the rock hits the water. Maybe we want to continue going on to see when it hits the bottom of the water, so we don't really know and can't come up with it. Well, for the height, how far down does the rock go? Well, we can roughly estimate the bottom of the river with some negative value, for instance, negative 20 meters. But we don't know for sure how high the rock flew because we don't know the k value, or the y coordinate of the vertex, directly from standard form. So we can come up with a reasonable idea for part of the domain and range, but we're unable to come up with the full idea. So thinking about standard form of an equation, we can confidently determine the y-intercept from the equation, as well as roughly part of the reasonable domain and range, and noting the y-intercept is the last value from the standard form.